In this video, I introduce DINO as a foundation for video world models. DINO is a self-supervised learning model that is applied to learn image representations by distilling knowledge from a teacher model to a student model, as shown here. This is a student model and this is a teacher model. Vision transformer is used as an encoder in teacher and student modules. Cross-entropy is applied on latent representations to train DINO models. The gradient only propagates, but not back propagates to the teacher model. Instead, its parameters are updated by using exponential moving average. As shown here, there's architecture of a DINO model. There's an input image, this is a full image. This is a partially masked image. This student model, this teacher model. Stop gradient used in the teacher model. Cross-entropy loss is used to train the DINO model. DINO-world is a video world model, which is trained to predict future frames in the latent space, namely predict the evolution of the physical world in all its complexity by acquiring a deep understanding of reality. DINO models here are used to understand temporal dynamics inside the video without physical environment reconstruction. The predictor is fine-tuned on downstream trajectories for action conditioned planning and control. Observations consist of a sequence of RGB frames with associated time steps, namely a video of T frames are represented as a tensor V, where Vt is a frame at a time t. A frame encoder pre-trained in self-supervised fashion encodes the video frames into a low-dimensional space for representation learning. The frame encoder learns strong semantic features of images so that the predictor is easily fine-tuned. Each frame Vt is mapped to a feature tensor xt, where d is the embedding dimension and h by w is number of the patches. The patch token x represents the state to be predicted. The video world model is defined as a mapping for future frame of prediction, as shown here, where x and t are past features and time steps, and tau t plus 1, I prime, j prime is a future coordinates for which a patch token is predicted. As shown here, this is a latent video world model architecture. This is a frozen DINO model. This predictor. We use a Q sampled from future queries, K and V sampled from outputs of DINO model, and then we condition down this action to predict the output in the latent space. To predict the future state at coordinates t, tau t plus 1, I prime, j prime, a query Q token from a learnable embedding across attains to key value pairs obtained from all previous patch tokens, followed by a multi-layer perception block as shown here. After the last block, a linear projection maps Q to a patch token x t plus 1 I prime j prime. The rotary position embedding is applied to multi-head attention to provide positional information. The head dimension dh is split into temporal, horizontal, and vertical coordinates of each token separately, as shown here. This is a horizontal direction, this is a vertical direction, and this is a temporal direction. The relative position defined on a -1, +1 grid is used in horizontal and vertical dimensions for position information, so that varying the input resolution will not change the relative distance between patches, as shown here. This is a -1, -1, this is a +1, +1, and this center point. The temporal coordinate tau is indicated by absolute time steps. The video world model is trained to predict a next frame, namely using the past t frames to predict the frame at t+1. Given a sequence of t frames, the model uses previous t frames to predict x caret t+1, I plus j plus at all locations I prime and j prime with Gaussian masking capital T minus t frames. Namely, a query for frame t+1 can only attend to patch tokens up to the frame t. The training objective is defined as here. Theta is the parameters of the predictor. L is the smooth L1 loss. If a downstream application involves the conditioning signal, for example, agent actions or language instructions, the agent trajectories are defined as observation action pairs V and A. Starting from a pre-trained video world model, the predictor is fine-tuned to predict the next frame at a time t+1, conditioned on the action at a time t, namely using action A to update the query queue, as shown here. T and V assembled from output of a DINO model, Q from learnable features. And this is the vision transformer with a Gaussian mask. This multi-layer perception. And then we condition on this action A to predict the features in the latent space. For more details, please check with these references. Thank you. Bye.